Finally, health has a role as an investment piece, so it's a form of stock or capital that you carry. So an individual's utility is determined not just today, but it's also a function of all of the other utility. You want to maximize your lifetime utility. So in that context, you can represent utility as a function of H in time period 0 and Z in time period 0, as well as next year's utility as a function. So that would be H1, Z1, and on all the way until omega, which is essentially the last time period of your life. So your utility today is the summation of all of those things. But you don't weight the future as heavily as you weigh today. So the future is discounted by delta. This delta here, which is the discount rate. It's what measures how much less heavily we weight the future relative to today. So health is a stock. It carries over, some of it carries over to the new time period. You know, in this model, Z, on the other hand, is just a flow. So your fun today isn't so much driven by yesterday's fun in the same way that your health, you know, you can invest in your health yesterday and reap those benefits now, or you can have some illness last year and today, you know, you still kind of carry it over. So health depreciates over time. So it's responsive to our investments, but also across the life course, it has this property where your health is depreciating as you age. Some of yesterday's health lasts to today, but not all of it. So here, gamma here represents the rate of depreciation of health. Delta was the discount rate for the future utility periods. Gamma is the rate of depreciation of health. Anyway, the point is that there is a rate at which your health depreciates over time. So health today is a function of, you know, the rate of depreciation times last year's health, as well as the time that you spend investing in health, and M, the market inputs, healthcare, weights, treadmills. So the marginal efficiency of capital curve is something that traces out the amount of lifetime utility that you get in return for each of your investments in health. So when your health is low, the rate of return on an additional investment in health is very high. So here the x-axis is your level of health, the y-axis is the rate of return to additional health, and the curve traces out how much of a health return you get from investing in your health, and it's going to be less when you're healthy and more when you're sick. So in this kind of model, there are two costs to health investment. One is the opportunity cost, and this is kind of represented by Z, the fact that you have to forego putting your money in other kinds of investments when you're investing in your health. So that cost is represented by R, which is the rate of return, the interest rate on the alternative market investment. That's the opportunity cost. And then there's depreciation, the fact that your health is going to be depreciating over time anyway. So in order to make an investment in your health worthwhile, it has to overcome both of those things, the rate of return on alternative investments and also the cost of depreciation. So the optimal level of health investment along that marginal efficiency of capital curve is the sum of R and depreciation of health. So H star is what represents that amount. And here is the point where the marginal cost of investing in health balances out with the marginal benefit that's the return to that investment. In the next video, we'll talk about these predictions of the Grossman model.